Yes, thank you. Can you hear me well? Yeah, louder, please. Is it now better? Yeah. Okay, thank you very much. So, RDFe is a model and a tool for mapping XML documents to RDF triples. But before speaking about RDFe, I would like to speak about XML and RDF. Here, we have a simple XML document, and it is obvious what it says. In 1936, the painter René Magritte created a painting with the title Clairvoyance. But it's less obvious how much we rely on our intuition understanding this message. The painting element contained by the painter element is about the painting created by the artist. So contained by becomes created by. And semantic relationship is inferred from structural relationship. It seems evident, but you would not be capable of writing a program which extracts this information unless the program was written with particular document types in mind. You can check this by considering the question, is an element describing a painter necessarily a descendant of the element describing the artist if the document contains such an element? And this is a rhetorical question, of course. This is not the case, and here is a counterexample. The painting is the ancestor of the painter. Yet we immediately understand this document as we understood the other one. We grasp the perspective conveyed by the document, and the perspective is encoded by hierarchy. If the focus is on painters, then the paintings are details described by descendants. And if the focus is on paintings, then the artist is a detail described by a descendant of the element describing his work. Hierarchy reduces complexity, but it also introduces a somewhat arbitrary choice of focus. And this choice streamlines a particular communication, but it is ephemeral. Tree structure is optimal for messages, but perhaps not for storage of information to be reused in unforeseeable ways in an unforeseeable context. The intuition aforementioned is defeated when we do not understand the natural language underlying the tag names. We are at a loss and do not know how to map the shape to the information contained. This RDF graph, serialized in the turtle syntax, captures the information conveyed by the previous documents. It is information purified, devoid of hierarchy. Structural hierarchy has been replaced by semantic relationship. A single graph expresses the semantic value of very different shapes. 3 different trees can be mapped to one common graph. And I would call this a normalizing reduction to semantic content. In the other direction, this content can be expanded into 3 different trees tailored for different needs. And each one of these tree shapes is like a different channel of publication of the information. If we have tools that can translate in both directions, reduction and expansion, very interesting opportunities may arise. For example, think of document-to-document transformation. Did it occur to you that we can validate such transformation by checking the semantic consistency of the target and the source. Okay, but then what gives me the right to say that this graph captures the information of that document? Perhaps you disagree. When we together look at XML, can we communicate what RDF we see and why? We need a model. So let's start with aligning RDF resources with individual XML nodes accepted as their representation and call those nodes resource nodes. The resource nodes serve as a point of departure when navigating to other XML nodes, giving us property values. And call these other XML nodes value nodes. When the value of a property is a resource, then the value node is in fact a resource node of another resource. Otherwise, that is when the property value is a literal, a string or an integer, for example, then these value nodes can be somehow mapped to the property values. And in either case, I think we may assume that for each property IRI, there is an expression which maps the resource node to the property values, and call this a value expression. RDF resources are identified by IRIs. So we must map resource nodes to IRIs. Sometimes this is easily possible, mapping XML content to the IRIs, but in other situations we will have to resort to external data sources which allow us a lookup given some of the lookup of the IRI given some XML contents. But in either case, our vehicle is again an expression which is evaluated in the context of the resource node and yields the IRI of the resource. So, looking at XML, we see resource nodes and value nodes. And we imagine value expressions and IRI expressions. And the gist of it all is a mapping of relationships. A mapping of the semantic relationship between an RDF subject and an RDF object to structural relationships between resource node and value nodes. And there is no better way of expressing structural relationships within a tree than XPath. XPath is a world champion. And for this reason, I believe that the quintessence of translating RDF into XML is a mapping of RDF property IRIs to XPath expressions. And that's what RDFe is about. Let's take a pull perspective. Our documents describe two resources, paintings and painters, with 3 properties each. So we need 6 value expressions and 2 IRI expressions. Now we write a document called a semantic map, which attaches to the resources and to the properties receptacles for XPath expressions, attributes, value attributes for value expressions, IRI attributes for IRI expressions. We fill them out and we let RDF pull the string of XPath. And that's it, essentially. You submit to an RDFe processor XML input documents along with 1 or several semantic maps, and you get a graph which captures the semantic content of those XML documents. So let's take a closer look at semantic maps. A semantic map has a target constraint, and an RDFe processor would never apply a semantic map to a document which does not meet the target constraint. It consists of the name and namespace of the root element and optional assertions. There are namespace elements specifying namespace bindings to be used by the RDF output. And there are resource elements which represent resource models. A semantic map is essentially a collection of resource models. And a resource model is just a recipe for mapping a resource node to an RDF description of the resource. A resource model has a target node constraint telling the processor to which XML nodes the model may be applied. The model contains a list of RDF classes to which the resource belongs. It has an IRI expression and a collection of property models. A property model describes how triples with a particular property IRI are constructed. The values are obtained from value expressions provided by the value attributes. So this is the resource model for painters, and here's the resource model for paintings. Note that the value expression may be accompanied by a type specification, giving us the type of the property values. And the type hash resource has a special and very important meaning. It means that the items returned by the value expression are in fact resource nodes. And the RDFe processor finds for each node returned by that an appropriate resource model, applies it to the node, creates on the fly a resource description for that node, and from that resource description takes the subject IRI and uses, uses it as the object of the triple which is currently under construction. And this is a very important feature of RDFe, that you do not have to worry about the IRIs outside of the resource model you are actually editing. The processor takes care of that. And these arrows indicate how the processor finds an appropriate resource model, which is in principle a mechanism reminding me of template matching in XSLT. So this page summarizes how a given RDF model, viewed as a collection of resources and their properties, can be populated by XML documents of various types. For each, so we have the painters document, the paintings document, and the Chinese painters document. For each document type is translated into the RDF model by a specific set of XPath expressions. And such a set is provided by a semantic map. So a semantic map translates or connects an RDF graph model with an XML tree model using XPath expressions as adapters. So the XPath expressions appear like moving parts transmitting the energy of an XML data engine to the abstract RDF model. Now, we have looked at how translation is controlled, but we must also look at how the scope of translation is controlled, what to include and what to omit. To understand the problem, consider the following scenario. You have a document about painters, and these data include lists of museums exhibiting works of that painter. And then you have this huge document about museums, all museums in the world, locations, opening hours, etc. You want to augment your painters graph with descriptions of the relevant museums, but please, only the relevant museums, those referenced by your data about painters. And this problem is solved by the distinction between asserted and required resource descriptions. Asserted resource descriptions are obtained for asserted target nodes. Now, what is that? Every resource model has an optional expression, asserted target nodes expression. When it's present, this expression is applied to all input documents, yielding the asserted target nodes of this particular model. The processor applies each resource model to each one of its asserted target nodes. And that's phase one of the processing. It is possible that these resources contain properties whose values are resources without an asserted description. And then the RDFe processor looks after it that those resources found as objects, those triples, are also described, again, by finding an appropriate resource model and applying it to the nodes. Now, these additional resource models are called additional resource descriptions are called required descriptions because they are considered required. But these required descriptions may in turn have properties with values not yet described. And so the discovery of required resource descriptions is a recursive process. Thinking again of our museums, we would simply not give an asserted target nodes expression to the museums, and this would have the effect that only those museums are described which are actually referenced by other resources. Okay. Now you have an understanding of the basic mechanics of RDFe, and we can glance at some advanced features. Semantic maps can import other semantic maps. A semantic map can define an evaluation context consisting of named variables and functions, and this enables you to use simplified XPath expressions. Navigation can be across document boundaries, and documents can be discovered along the way by following links found in the data. Using conditional properties, you may adapt settings of a property model to the value returned by your value expression. For example, taking advantage of links if they are present and staying with local nodes otherwise. RDF list, reversed and inverse triples are supported. And finally, you are supported in your quality control by supporting cardinality constraints, which you can attach to a property model. And if a property is provided with more or less value items than you expected, a warning is raised. To illustrate some of these features, again, a scenario, you have a catalog of paintings which give you much more information about the paintings than the document about painters had. And you want to leverage this information and augment your graph about painters. And this catalog of paintings comes along with its own semantic map. So how can you pull in this information into your semantic map about painters? That's very easy. You just add an import of that semantic map about paintings, and then you edit the value expression of the property which points to the paintings. You use a new expression which navigates into the catalog and selects the element from the catalog which corresponds to the local element because it has the same title and date, for example. So here's the output before our editing, and here's then the augmented output. The XPath expression, diving into the catalog document, was a bit convoluted. and you can mitigate complexity by defining an evaluation context consisting of named variables and functions. Oh, sorry. The variable, the values of the variables, as well as the bodies of the functions, are defined in terms of XPath expressions, which are then evaluated in the context of an input document, its root. So here we take advantage of such a context in order to define a function getPainting, which selects from the catalog an element about a painting with a given title and date. And lo and behold, we get a very simple value expression. And it's an important detail to understand about context that for each input document, a distinct instance of the context is instantiated. So with that document as a context. And this means that the context can capture some information about the individual document. That's an important aspect. Sometimes you want to modify property settings in response to the values which your value expression returns. So our value expression gives us painting elements. And now imagine that a painting element in our painters document has an optional Wikidata ID attribute. And this attribute can be used for a lookup of more comprehensive information in a catalog. So when it's there, we want to take advantage of this. And when it's not there, we stay with the local element. This is simply implemented by using a value item case clause, which checks, is it there? If not, everything remains as it was, and the local painting element remains our resource node, and otherwise, we continue navigation into the catalog and do our lookup. But that's really a quite advanced feature. You may wonder, do we need RDFe if we have RDFa? As you know, RDFa uses additional attributes, that's the A, in order to augment an XML document with semantic information. And my answer is yes, we need RDFe because they are complementary. RDFa is for text-oriented, human-authored XML, where the markup is layout-oriented and gives you no clues as to the semantic content. And there, in this scenario, it's absolutely appropriate to add attributes to give you this information. But RDFe is designed for data-oriented, machine-generated XML, where the markup is semantically rich. In this setting, RDFa would be downright inappropriate because you modify the documents, breaking schemas and cluttering content. RDFe, on the other hand, is non-invasive, and it lets you leverage the information contained by the markup to the fullest. So RDFe is meant to lower the barrier that separates RDF from XML. Given some data-oriented XML, no matter how complex and no matter how distant from the RDF vocabulary you have in mind, an RDF representation should only be one short, simple step away. That's writing a semantic map. And the perspective is emphatically not a single document one. RDFe is designed to support the translation and connecting of the content of multiple documents with multiple document types and possibly iteratively discovered. Currently, an issue is performance. When the volume of input data gets larger, performance gets really, really poor. And I found Michael Kay's presentation yesterday very encouraging that this can be healed. But at any rate, at the moment, I think this is not a fundamental problem, but it shows that the reference implementation is rather naive. And the ideal would certainly be RDFe support built into an XQuery processor. Wrapping up, I believe that XML and RDF are complementary technologies much more than is usually thought. To take advantage of this, we need tools that let us move between them lightly. RDFe is a tool and a model for this. And it is my hope that some people will find it useful, but it would be my ideal if some people found it useful and inspiring. Inspiring them to see the RDF in XML and to see the XML in RDF more clearly. Thank you very much.
Thank you. Perfect timing. Ah, okay. Over there, Katja.
Brilliant. I really enjoyed this, and I think it's a great idea. And I liked. I mean, I was going to ask you about RDFa, but then you went and talked about it. But I wondered if you'd already considered about mapping the input into the same structure, but then with RDFa attributes decorated on that tree.
Yeah, that's a very interesting idea, and I have not considered it. Yes. Yeah, very interesting indeed. Yes. Automating the production of RDFa.
Yeah.
Okay, I think the rest there and so there.
Yeah, thank you for this interesting talk. It reminded me a bit of a standard called Griddle. Gleaning resource descriptions from dialects of languages. Have you compared it to that? I'm not sure how it compares.
What was the name? I didn't catch it.
Griddle.
G-R-D-D-L. No, I think that's absolutely deceptive, because this Griddle, that's just about how to locate and some opaque translator. It's not at all about how to translate. So
it's just to locate, but not a translation.
I mean, it's just about how to find the link to a resource which gives you that, and it leaves you absolutely, gives no thought even to how the translation is accomplished.
Thank you.
Yeah.
Come on.
Thank you, Hans-Juergen. Over here.
Over there. Whoever comes first.
Thank you, Hans-Juergen. I have a question. I also had a couple of small comments. I'm not too sure that RDFa is not for adding semantics.
Again, please.
I'm not sure that RDFa is not for adding semantics rather than layout information.
I mean, of course, you can use it for any XML. But only my argument was that it is appropriate, or more appropriate, if you have no other means, and you really need the manual addition of information. Yeah?
Okay, but anyhow, my question was, have you compared, we already heard one example, but there are standardization efforts for virtualization of all sorts of database formats. to serve as a basically Sparkle endpoint on top of any sort of data. So standardization efforts are going on in that direction. Have you checked that out, and have you compared your work with?
Yes. Well, I'm not an expert about these rule set, but I think there's one huge difference. XML is deep. Yeah, and there is, as far as I know, and I have reasons to think that I'm right, there are not at all standards, not even attempts to achieve this mapping of deep structures. I mean, what is the closest to it is JSON-LD, but JSON-LD maps just the name. It assumes that you have the same structure in your tree as in your RDF. So in other words, you have a node representing a resource, and the children are bound to represent the properties. Yeah? And this is absolutely unusable if you come when XML first, when there is some given XML, when you have not designed the XML for the purpose. And yeah, as I said, consider that all these, for example, CSV and relational, it's all flat. So it's essentially a mapping of names and how to deal with links. But it's never considered, as far as I know, how to handle the navigation in a deep structure.
Okay, fair enough, thank you.
Thanks for that talk, I enjoyed it. It's fairly similar in spirit, I think, to something I presented at XMLPrague a couple of years ago that we have built into Mark Logic, which uses XPath to find pieces of documents and turn them into triples inside the product. I think there's interesting some of the things that you have that we don't have. I mean, your format was a lot more declarative. We just had XPath for subject, predicate, and object, which is, I think, sometimes more flexible, but also you've got more semantic information about like which things are properties and in your actual description. And it does share some commonality with JSON-LD context, I think, as well, because you can use JSON-LD context as a standoff description of how to get semantics out of JSON. And I think what you've done is the equivalent for XML to be, a standoff description of how to get semantics out of an XML document. So I'm going to go and investigate this more, but thank you very much for presenting it.
I would like to make the remark that I have studied JSON-LD for a long time and very carefully and learned from them. But it is, as I said, they are just not at all prepared, because in their thinking there is no such thing as a path. And it's something which I find such a pity that this is not, in my opinion, appropriately recognized and understood, that XPath allows a way of thinking which was not possible before XPath. And JSON-LD is a brilliant example. It doesn't even occur to them that there could be something like a path.
I have another question, please.
Okay, one last.
Here I am. Thank you for this really interesting presentation. I have just a tiny question about the resource. You're using target element name, and you're not using XPath to the painters, for example. Is just located on the name of the tag element. Or maybe I didn't understand.
I'm not quite sure if I understand you correctly. I mean, in the semantic map, there is a pull perspective. It describes RDF model and then how they can be applied. So, but there are XPaths used, in fact, can be used for assertions, for example, to say you can apply this model only to a path if it appears at the path A/B/C, you could say that. But I'm not sure if I understood you correctly.
I'm not sure. So just it was about the constraint on the name and the namespace.
Oh, yes.
Okay.
That's primitive. That's primitive. I mean, that's not really developed.
Okay.
I just said an optional assertions, but I strongly feel myself that this has to be elaborated. Although you can, of course, achieve any effect if you allow assertions. That means arbitrary XPath expressions which have to return a Boolean true. Yeah?
I was thinking about the title element, which can mean different things. The title is a...
Pick it offline.
Okay, thank you.
Thank you. Thank you very much. Lots of questions.